Okay, I think we are ready to start. Oh, it's really great to see you guys. Hi, Bruna, I see you. Okay, I close my phone. Yeah, guys. So today is the second day of our seminar. So before we start, I suggest to turn on your cameras if it's possible for you, and we say hello together. This is our tradition in aerial robotics seminar, camps, and other activities. So we say hello together, and then we will start our final day of our today's seminar. Oh, hi, Cesar. Okay. Oh, hi, Kirill. Oh, hi, Davis. Anybody else wants to join us with cameras? Today will be a very interesting and difficult day for you, but we will check your power in the drone learning technologies. Okay, guys. So before start, so say hello together. You can unmute your microphone, and we will check it in 3, 2, 1. Hello.
Hello.
Hello. Hello. Hello. Hello. Great. Great. Nice to see your smile on your faces. And so, are you ready to take a common photo for our social media groups? Okay, I see many of you is ready. And take a common photo in 3, 2, 1, smile. Great. And one chance to repeat the steps and get the best photo in 3, 2, 1, smile. And the last chance, especially for you. Are you ready? Very smile, guys, very smile. Good hair, Bruno. 3, 2, 1, and smile. Hey, great, great, perfect. Okay, thank you for your good mood, guys, and we are ready to start. Start right now, and I'm going to share my screen, my presentation for today. Just a moment. Okay, I hope you can see my screen. Okay, great. So today the second day of our aerial robotics seminar, and what we expect to know to do today. So this is our program for today. So today, Timofey and Lena will tell you about Python for programming Clover and how you can edit their world in Gazebo simulator. Some words about computer vision. Then we will have a coffee break time, 10 minutes, if you want, of course. Then we will talk about the color object and how you can find and determine the color using OpenCV libraries. Then we will provide your favorite mini game. And finally, we will tell you, we will give you information about CopterHack, and we will finish our seminar by evening briefing. So I hope you are ready to start. Yeah, guys. I didn't see any messages in the Zoom chat. Please write plus or something else if you are ready to start. Oh, great, great. Let's go. Okay, you are ready, steady, and go. So today, the classes will be provided by Timofey and Elena. And before we start, I would like to share with you one interesting thing. So maybe many of you knows about our educational materials, but I would like to demonstrate it for you again. Just a moment. Yeah. So this is our website, and on our website you can find the page named Education, and on this page you can find some actual information, but you can oh, what's happened? Yeah. So you can find many useful information and also navigation with these materials. So we will demonstrated some information about Clover, about our community, about the features of Clover. And on these videos, you can find and you can learn more information about Clover platform and about Clover application in any research projects. Then we have a part of educational trajectory, starting from working with hardware and software, and then you can go to the competitions and project activities. So in our hardware part, we start from the safety and instructions and manuals about how to assemble the drone, how to set up the flight controller, and how to provide the first manual flight. Of course, safety comes first. Some words about software. So we have a step-by-step guide on autonomous flight, and also on our YouTube, you can find the webinar about how to set up the Clover autonomous flight. And yes, this one. So this video will help you to pass all steps, to repeat all steps and perform your first flights in the autonomous mode, safety without crashes. And of course, information about Gazebo simulation from our webinars and camps. Some information about the competitions. So you can find actual information about most popular competition where you can use the Clover platform. And of course, project activity. So this is examples of the projects. So it's one of the popular projects. Also, you can find more information about projects on our Gitbook. So for example, read more, and we go to our Gitbook, can read more about this project. but more projects you can find on the CopterHack 2021 in this table. This table consists of the completing project with the description, with the files for 3D modeling, for example, or some codes examples for the drones. So, and also our library with curriculums, textbook, manuals, and video materials about Clover. So to learn more or to collect all information which we shared with you during our camps, you can find on our YouTube using these links. And also we saved all materials such as the presentations on our Google Drive folder, and you can choose language and find required options and find more information. For example, we can open webinars and find all information regarding to this seminar here. Yeah, so that's all from my side. So if anyone has questions, I will be glad to answer it. But now I didn't see any questions. It's okay, but I see that you are ready to start our classes. And Timofey, Lena, are you ready to provide the classes?
Yes.
Okay, perfect. So guys, I wish you good luck in your strong training. Timofey, Lena, welcome.
Thank you. Let's begin. All right, so the first topic for today would be writing your programs in Python. And let's just recall real quick what we learned yesterday. Yesterday we installed virtual machine, and right now I can even run my virtual machine because I will need it soon. We also learned how to program a drone with blocks. And we saw that blocks will also produce the Python code, but we didn't go deep into Python programming yesterday. And today we are going to begin with this. So where do we start? First of all, there is a module for Clover. You can see the beginning of most of the programs that you will write in Python for Clover, and you will find more information in this source. This is the article called Autonomous Flight of Board. I showed you this article yesterday, and there's a good example of the code that you need to use to start your program. First block of code is imports. So you need to import ROS.py for working with rows, and also you need to import some services from Clover package as well as some standard services to import trigger. You don't need to know exactly how to write this by your memory because you will always copy this from the website. So you don't need to know it in your memory. You just can copy, and you need to understand the basics of what's happening here. The next part is calling the init node, ROS.py init node function, which will actually declare this code as a ROS node. Before you do this program is not a ROS node. Once you paste this line and enter some name, it's a random name, but there should be no two nodes with the same name, so it should be unique. You now are able to work with roles. For example, you are able to call services or to subscribe to some topics. And this is, you may change this name if you want. Then there is a new variable called getTelemetry and navigate global, and so on. And you create the objects, the service proxy objects. So these objects are actually the Python way to call services. And this is how you construct these objects. You can call by service proxy, give some arguments, the name of the service and the link to this service in SRV module. And you will be able to call the getTelemetry service now. If there is no this line, you cannot use getTelemetry in your code. As well as navigate, the service that will move the drone from one place to the other, mostly used one. You also need to make sure that in your code that there is this line. And now let's proceed to the real programming. Here in the simulator, you can open your home directory and create a folder where you will store your programs. Let's create this folder. Right-click, create folder, progs, like this, progs. It's a random name, I just chose this for convenience. Now let's open Visual Studio Code and open this program, this progs folder in the Visual Studio Code. You need to do that because it will be much easier to work with multiple programs at the same time. So File, Open Folder, and go to Clover here, Progs, OK. And now on the left you have the block where you can add your programs, like this new file. Let's call it 1.py, and now you can add some code here. So where is the code? You can copy this code example and paste it in this 1.py program. And then let's start programming. First of all, we will call the navigate service. How do we know how to write it correctly? Let's scroll down here and find navigate. Here, there is an example of how you can take off to the 1.5 meters with the speed of 0.5 meters per second. You need to write navigate and specify these parameters. Some of them are zeros, so if they are zeros, you can just skip them because 0 is the default value for them. And let's write it ourselves. I can copy this, of course, but I will write it myself this time. So navigate, and I will write z equals 1.5. Then I need to specify frame ID. Oh, frame ID equals two quotes, and we need to take off in the frame ID body. So we will use this 1.5 meters, and the reference would be the body of the drone. So it will draw a line straight up from the drone, and the drone will try to reach this point. Then we need to write auto arm equals true. It says that if the drone wasn't armed, it will do it now, and after it arms, you no longer control your drone with your RC controller. You can only get back the control after switching the flight mode switch. So now the drone is in off-board flight mode. Now what next? The next part is navigating to a certain point in the Aruka map. So But I forgot to do one thing. Before calling the next navigate, you need to give some time for the first navigate to be performed, because I also didn't specify speed, and the default speed is 0.5. Let's change it. Let's use actually speed equals 1, so it will take off faster. And now let's give the drone like 2 seconds of waiting time to make sure it has reached the height of 1.5. It's done by rospy.sleep 1 or like 2 seconds. Yes. And then we can use another navigate. I will copy this one and paste it there. So I just put my cursor here, Control C and Control V. And I will also provide some X and Y coordinates. X equals 1, Y equals 2, speed equals 1. And now frame ID should be changed to Aruka map. So now the drone will just go to this specific point relative to Aruka map. And you don't need to put auto arm true anymore because it is already in the air. And always remove it after you have already taken off. And let's count how many seconds do we need to get there. Well, it's about 3 seconds, I guess. So cross by sleep 3 seconds. And now we can call the land service to land in this point. So this is a working program. Let's check this out. Let's try Gazebo. And there are 2 ways how you can run this program. The first way is easier, but it will only work in the simulator, is by clicking this play button. So here you can see the drone is ready to fly, and I will click this green play button. And let's wait. Yes, the terminal appeared, and the drone is starting to move. Takes off, and it goes to, okay, it doesn't go anywhere. Let's see what's wrong here. Aruka map. Can snap requires. Yeah, the reason is I forgot to. Wait, let's see what's the reason. Aruka map. Maybe. Let's try again. Oh yeah, now it is going. Yeah, now it's working. So the drone from the second attempt did what I wanted it to do. And I think 3 seconds wasn't really enough because it just started to land immediately after it reaches the point. So it's better to have maybe 4 seconds. But what happens if we run this program again from this point where it's already in this position? Let's see. Just run it again. It will take off from whatever place it wants, but now it just fixed its position a little bit closer to its marker and landed. Not perfectly, but still in this marker. And the coordinate is 1 meter x and 2 meters y. So this is the easiest way to write Python programs. But this way is not very convenient because you have to always enter waiting time manually. You need to calculate it and sometimes you may mess up with this. There is a way you can actually make the drone determine by itself whether it has reached the point before going to the next point. And blocks programming does this, and you can see how it's done in blocks programming, and then we will do the same thing in Python programming. So let me open Firefox. And localhost, block programming. Yeah, and you can click Python to see how it is working. So instead of calling navigate, it is calling navigate wait, which is the newly created function. So this is the function navigate wait. It has some arguments, and this function is actually calling navigate, normal navigate, with some additions, like it's calling res, it's making the res variable before calling navigate to store the response of the navigate function. Well, we will not do it while programming it manually, so just make sure you understand this, but you can do it a different way. And now let's create navigate wait ourselves. The best way to do this is to go to the documentation. Let's find the documentation and the article called, where is the article? Code snippets, yes. This is the code snippets article. I will give you this one. And the first snippet is called fly towards a point and wait for copter's arrival. And it says you need to import math first, and then some skipped code, and then the function. Let's import math. This is a module that has some math functions and calculations. Oh no, I should write it in this program. Okay, import math. Then we need to import, we need to create the function called navigate wait. Let's copy this function. And the best place to paste this function is after service declaration. And I will usually change some parameters in this function. So for example, the default z is 0, but I want it to be 1.5. And the default yaw is float none, which will just not control yaw at all. But I like to use 0. And also the default speed should be 1. And the default frame ID, Aruka map. And now this function looks good. You can now try this out, and let me quickly explain what it does. So the first thing the function does is calling the normal navigate with the arguments of what we entered as arguments in navigate wait. So as you can see, x of navigate is equal to x to this one x, which is actually 0 in this case, and so on, and every next argument is determined the same way. And also we have tolerance argument, which is not in navigate, and this is used as a error that's allowed for the drone to count the flight to a point. So if the drone is at least 0.2 meters from the point where it's flying, we think it has already reached the point. until it's 0.2, it's not reached. It hasn't reached. And the next thing that's happening here is the while loop. I hope you're familiar with Python, and this while loop will be performing, will repeat the code under itself until this returns true. I mean, when it is true, it will repeat and repeat. Once it's false, it will stop repeating. So before every next run, it checks whether this is true or false. So this is just a ROS way of typing loops. So while not_py is shut down, we will just make sure that the program wasn't interrupted by Control-C or by something else. So in order to interrupt the program, you need to press Control-C. And the next part of it is you create a TLM, the TLM variable, and here in this variable, you call the service getTelemetry with the frame ID of navigate target. And getTelemetry will actually return you some lines of information. Let me show you what getTelemetry will return normally. So let me take off for now, and I will show you. Commander take off. While it's taking off, here I will call telemetry. Service call / get tab again. And this in frame ID, you can write argmap. And here is what getTelemetry returns. It gives you the coordinates 2 and almost 3, like 2.59z and 0.79x. Also the speed, velocity on each axis. Pitch, roll yaw, pitch rate, roll rate, yaw rate, which is angular speed, and some cell voltage and full voltage of the drone. All right, and when you call telemetry and use frame ID called navigate target, it will give you the telemetry relative to the point where the last navigate was sending the drone. For example, in this case, the drone was sent to the altitude of 1.5 meters, and the coordinates were 1x and 2y. And now the drone is hovering higher than 1.5 meters, which means that z, in this case, is 1.14, which is, if you combine this value with 1.5, you will get, what you will get, 2.6 or something like that, which is the actual height, the altitude of the drone. And the x and y are almost 0, so the last navigate target gave you the distance from the drone to the point where it was sent by the last navigate. And this is useful because we can calculate how far away we are from the point where we are going to. And in this case, TLM will store these values, and then we will use them to calculate the distance between the drone and the desired point. And here, there is a if in the block of that asks, if this returns true, then break. So what is if here? You get math sqrt, so square root of these values, tlm.x, which is the x position of the drone, power to the power of 2, plus tlm.y to the power of 2, plus tlm.z to the power of 2, and you get square root of it. So this is the Pythagorean theorem. For 3D space, you will just get the distance from one point to the other. And if this returned value is less than tolerance, then you are close enough to the point to go to the next one. I hope this explanation is easy to understand. Some of you may already know this code anyway. Let me continue. So if it happens, then you break out of this while loop as well of the whole function. So after you break off this loop, there is nothing left in this function, so the function is over, and you can start another function, navigate wait. But if it's not true, then you will just sleep for 0.2 seconds. And now let me write some code based on navigate wait. Navigate wait. For taking off in navigate wait, you just specify the frame ID equals to body and auto arm equals to true. And now you don't need to wait for any longer. You can just go to your point. Why didn't I say go up to 1.5 meters? Because 1.5 meters is already here. If I want to change it, I will, and I will now. So navigate wait to the coordinates of, let's go to 3 and 3. And now I don't even need to write the names of the arguments. So I just paste values and they will go in the order. So the first one goes here, the second one goes here. So navigate wait to 3, 3, and the third one is already 1.5, which is fine. Okay, I copy and paste this line several times, and let me change it something like that. Oh, what did I do? Like this, and then land. Let's check out how it works. So let me first commander land here, commander land, and run this program. And this time I will run it from terminal, not from Visual Studio Code. So to do it in terminal, I opened another terminal, so there are two tabs, and in this tab I will go to cd pr tab, and now Python and 1.py. Did I save this program? Yes. Run. And the drone is taking off. Let's see. It is taking off, and then it will go to the 3, 3 first. It is going here. Then it will go here to the 1, 3, then to the 1, 1, then to 3, 1, then to 3, 3, and land there. All right. Is it easy? Let me show the program again. Is there anybody who never programmed Clover? Can you write in the chat if you understand everything here and if it's easy for you to understand? Or maybe you have some difficulties to understand this. Because now we will proceed with the next topic, and I want to make sure that you understand this one well. Okay. So this was navigate wait. And if nobody wants to ask anything, I will go to the next topic, is editing Gazebo worlds. So you can change your environment in Gazebo. You can add some models, and you can interact with them. Let's do it. First thing I want to do is to show you some parameters of the flight controller. Let me open Q-ground control. This is the software used for controlling your flight controller. So this is a ground control station. I will change these to metric system. Okay. Yes, and it will work with real drones as well as the simulated drones. And let's go to this menu, vehicle setup, parameters. And I want to find the parameter called EKF2 HGT mode, so height mode. What to use to determine height of the drone. And the basic range sensor is good, but it gives you some unwanted effects. Let me show you the effects the range sensor height will give you. Let me just let me comment out Control/ to comment out all these lines. And run this program just to take off. And I will show you the effects that rangefinder will give you, which we want to avoid. Okay, the drone is in the air. And if I put a box below the drone, the rangefinder will detect the change of the altitude. And it will go up so high just to maintain 1.5 meters, which is, as you can see, not really good. And once I delete it, it will go back. And to change this, we have a selection of a few sensors. I recommend you using vision or barometric pressure. So barometric pressure is not very accurate and it might drop sometimes. And vision is very accurate, but it will only work when it sees some markers. And if the drone doesn't see markers for a long time, for example, if it's standing on the ground, it may cause some troubles in flying. But I will use vision because it's the most accurate for now. And it requires a reboot, so I will reboot the terminal. But I will reboot it a little bit later. For now, I'll just show you how to edit models, and then I will reboot the whole thing. Let's land the drone. Commander land. And to edit models, first thing I recommend you to do is to delete Clover from the scene, because after you enter model editor, you will not be able to fly anymore. And if you want to save the world in Gazebo, you should also remove Clover, because otherwise there would be two Clovers that will cause some problems. So I hit delete, and there is no Clover. And now you can even stop the simulation here, pause the simulation, and enter the editor menu. So here I have box. I will use it as a reference model and hit it once, right click, edit model, and I will create a small tile or a colored tile of this box. To do this, I will first need to change its geometry and then its collision and the color. So I select it once again, right click, open link inspector. And here in visual, I need to open this menu and find the geometry submenu. And enter here 0.5x, 0.5y, 0.02z, and tap. As you can see, it changed the visual representation of the model, but there is a still bounding box that will hit other objects if I not change it. So collision, geometry, I will enter the same values. Okay, and go back to visual and scroll down. Let's create a green box, a green tile. So I will reduce, well, I can just increase some green to 1 here. And here in diffuse, increase it to 1, and the rest would be still the same. It will give you not the perfect color, but a little bit more dirty, which is more close to the reality. But now it looks inaccurately because it's the editor. It looks like that in model editor. Hit OK. Then I will go to model and hit static because I don't want this model to physically interact with objects. I want it to be stable and made of impossible material, so it will never move however you crash it. And now you can file save as, and let's call this one green. And save it, well, the default location is home Clover model editor models green. Let it be here for now, but we will move it out of this place later. Save, file, exit model editor, exit. And as you can see, it's green. Well, I think it's not green enough. I think we should better change some colors to make it more green and make it as green as it's underneath. So right-click, edit model, select, right-click, link inspector, visual, and let me remove diffuse, the red diffuse and blue diffuse, and put it to 0. All right. Okay, file. You can just hit exit model editor and save and exit and green, save. Yeah, now it looks better, in my opinion. How do we create another model, the same model but with a different color? Select it, right-click, edit model, right-click, open link inspector, visual, scroll down, and now let's change the color to red. So here, instead of 1 in green, we will paste 0.3, but we will have 1 in red. And here we will have 1 in red in diffuse and 0 in green. Those are different parts of the color. This is, you can play around with them to understand what they do, but basically ambient is the basic color of the model, and diffuse is the color when it's shining, like when it's reflecting something. I mean, not reflecting, but when it's enlightened, when it is exposed to some light source. All right, so okay, and now file save as red, save, file, exit model editor, exit. All right, and how do we add more models like this? In the insert tab here on the left, hit insert, and you can scroll down to find model editor models, red and green. You can put as many of them as you want. And remove this one. Now they are on the ground. Let's reorder them, reorganize. I will use this tool, translation mode, and I can drag them around. All right, so this is our model's layout. But now let's create another type of model, also based on box. Right-click, edit model, I will create some sort of gate. Open link inspector, visual geometry. Let it be very thin, 0.1, 0.1, and the height, let's have 2 instead. And here, collision geometry, 0.1, 0.1, and 2. Okay, but now look underneath. It's piercing the ground. And the center, the origin of the model is here on the top. We need to change this. Let's right click it, open link inspector, link, and there is, let's see. I think it should be in pose. Let's try. Yeah, if you change Z pose in visual to 1 and Z pose in collision to 1, now the origin is at the bottom of the model. All right, and now we can also copy this one, Control C, Control V, and let's actually put it not by our mouse, but we enter values where it's located. So right click, open link inspector, and let's see. Here in link, there is pose, and we will use 0 in X, -1 in Y, and 0 in Z. Okay, looks good. And I think we can now save this model. Is it static? No, but use it as static one. File save as, it's not really a gate, but columns. Save. You can actually put a bar on top of them as well by pasting and rotating this thing like this. There is this tool, rotation. If you click one axis, for example, a red one, and hit Control, it will go in straight angles and 45-degree angles. And you can actually move it up the way you want, in the place where you want it to be. And the coordinates should be 1.5, I think 0.5x to z. Let's check this out. Edit. Link pose, so 0, okay, 0.5y and 2z. Okay, it's not really what I wanted to have, but it will work. File save, and the file exit modulator exit. Here we have the model. It's located in air, in midair, so I will delete this one, and insert a new one, columns. So really good. Very nice. Let's save this world now. So to save the world, you need to hit File, Save World As. Let's call it somehow red, green gates. And I will save this world in the certain location. In the location where the original world is located. So you go to Catkin WS SRC Clover, Clover simulation, resources, worlds, and here there is Clover world and Clover Aruko world. Hit save. Now you can close the simulator by Control C. And now we need to enable the newly created world to be the default world. So I will open Katkin WS SRC Clover simulation. So as you can see, it's in worlds. So red green gate is here, but I will go back and back to find the launch and open the simulator.launch. This file is a launch file that controls like how to start Gazebo, how to start simulation, and so on. So here you will find the line number 17, and it says that you will use Clover Arupa World by default. But we will need to change this line to find the world that we just created. So it's red green gate. Let me copy the name of it. And instead of Clover Aruka, I will paste red green gates. Save. And now I can run Gazebo. Let's see. Yeah, I think there is some error now. Yeah, it's not loading correctly. The reason is yeah, the reason is very dumb. We forgot to enter that world extension. That world rename. And now that should work. And as you can see, the drone is here, the world is here, and we can fly in it. Yeah, let's quickly fly through these gates. You need to fly with y equals 1. Okay, let's change our program. Go to 0 and 1, then to 5 and 1, then 5 and 0, and 0, 0. If you want to fly to 0, 0 coordinate, you just keep the parentheses blank. You don't need to enter any values because it's already 0, 0 by default. Save and run to fly. Look at it. It's working great. And now if you put a box here, the drone will not bump up as it did before. Let's run the program again. The drone will stay in the correct altitude. Oh, and as you can see, now it jumped and then slowed down because of the vision way of determining height. working great. Yeah. So what's next? So the next part would be OpenCV in Clover. This is maybe more difficult than what we did previously, but anyway, we will go through it. And that's, if you have any questions regarding previous topic, you can ask. But for now, I will start explaining you the basics of OpenCV. So first thing you need to understand is which color spaces should we use. By default, the cameras will work with RGB. And this color space is represented here. It has 3 axes, red, green, and blue, and everything in between them is a certain shade of color. Yeah, and the black is on the corner that's away from us, and the white is on this one. But it's not the best option for color recognition. The best option for color recognition is HSV, which is hue saturation value. And this is a different color space. It looks like this. And you can very precisely set the hue of the color, like a range of colors that will count as the object that we want to find. Because any colored object has different shades in it. If I want to find this orange, I need to be able to detect all the different shades of this orange. And the hue of them will not be very different. So maybe from here to here. But what's more important is the saturation and value. Well, actually, value will vary the most. And saturation is how far away the color is from shades of gray. And the value is just the lightness, the brightness of the color. Okay, and for this glass, I think it would be maybe saturation close to the extreme position, like here in this range. And the value would be like from here to here. So you will have a piece of pie, and each color inside this piece of pie should be approximately look like one of the colors of this object. And you cannot achieve the same effect with RGB, because in RGB you operate with cubes with these boxes of color, and they change in hue very drastically. So if you want to have a wider range of color, it will also detect a lot of colors that you don't want. For example, this one is from it's from blue to purple, but we want to have a narrow color space. Anyway, let's go to the next slide. So as I can see, red, green, blue, each color component has a range of from 0 to 255. BGR is the same as RGB, but in different order. And in OpenCV, this is the default color space. And HSV is hue saturation value. And in OpenCV, hue goes from 0 to 179. But in most cases, you will find, well, away from OpenCV, you will find it will go from 0 to 360. So it's 360 degrees. But here, in order to fit in 1 byte, they had to reduce the range and count 2 degrees as one increment of the number. Saturation and value will also be from 0 to 255, and HSV is the best choice for selecting color range. Okay, the next thing about OpenCV is that it's working with image coordinates, and you have x-axis and y-axis, and they have 0 in top left corner, and x goes right, y goes down. And for example, if I'm here, if this screen is like 1920 by 180, then this coordinate will be something like 0x and what is it, 560 in y. Well, you get the idea. And you can find the documentation, the basic documentation in our website, but there's not so much theory here. There's more code examples, and once again, I have a robot behind me, so you can hear these noises. I will shut it down soon. So we will work with this very soon. Yes. And the first thing we need to understand about working with OpenCV, well, maybe not the first one, is that here we have camera, and the image from this camera is found in a topic. And in order to get access to this image, you need to subscribe to this topic in your code. Let's open these code examples. So this code will subscribe to the topic image camera, main camera image row. But we need to create a special topic for our OpenCV purposes, because image row will update too frequently, and subscriptions work in a way that whenever a new message appears, it will process this message with certain code, and if this code is heavy, it will load your machine, load your Raspberry Pi on the drone or your computer if there are too many messages. And we want to have less messages in the topic. And to do this, we will create another topic called image row throttled. So we will throttle down the original image row, and to get less frame rate. To do this, there's this code that we need to paste in the file main camera.launch. Let's find this file. So for now, I can close the simulation, and let me find this file. Catkin WS, SRC, Clover, launch, main camera.launch. All right, and here we need to paste this line. How do you find it yourself? It is in this article that I will give you the link to. Okay, this is the link. Great, and if you scroll down to the bottom, you will find, right before video recording, you will find this line. So this is about the script for reading QR codes in Python, but it also applies, this part also applies to any type of image processing. The script will take up to 100% of CPU. To slow down the script artificially, you can use throttling of frames from the camera, for example, at 5 Hz. And let's copy this line from here. It's actually one line split into 2 lines. And here, after the final /node line and right before /launch, you will enter this new line and leave it like that. You can just have it as 2 lines, which is fine. Otherwise, you can erase this, but then don't forget to put a space bar between throttle and args here. And save. And now you are having 2 almost similar topics, but one has less frame rate, which is 5 Hz in this case, because we put 5.0 here. If you want to change it to 2 Hz, you can do it as well. All right, and now let's go to the next step. So this is the example code. Well, it's actually the same as, where is this? Yeah, here. I will create another program. 2.py. Okay, and what it does, let's see. Import ROSPy, import CV2 from sensor, import image, from CV bridge, import CV bridge. Well, CV bridge will actually allow you to exchange images between OpenCV and ROS, because these types of messages are unsupported by default, and you have to use bridge to do this. The next one is ROSPy init node, computer vision sample. So this node will be called computer vision sample. Then you create the bridge object, CV bridge, and you create a callback function. This is called image callback, and it accepts 1 argument. What is callback? Callback is a function that is passed to the other function in arguments, or in another object in arguments. So you do not call this function manually. You call this function, well, it is called automatically inside of other function. And this function is called automatically whenever a new message, image message appears. But you need to change here in the subscriber. So you can see image sub is the object for subscriber. We have for SPY subscriber. The topic name, image raw, but now we need to use another topic name, image raw throttle, because we just created this one, and which has less frame rate, which is great. Then you paste the image, the type of message, and then the function, image callback. This looks the same way for any other subscriber. So if you want to subscribe to other topics, not image topics, but to some other, you will create some other sub call equals some ROSPy subscriber, your topic name, then the message type, then the function that will be called on the subscriber. All right, and what can you do here? This function does nothing for now. It only gets the CV image. What is CV image? CV image is a new variable that will be calculated with this function, the bridge function, the bridge method, the method called image smg to CV2. And here you paste the data as your first argument. It will be passed automatically in the subscriber. So you do not do it yourself, and it is pasted automatically when this function is called. And then the color space, it's BGR8. So it's blue, green, red, 8 bits. which is the normal for OpenCV. And you will not notice any change, but to notice some change, you need to do something like that. For example, CV, I will print some information from this topic. And what is CV image? I can print a part of it, CV image. It's a NumPy array. It's a multidimensional NumPy array. And it works similar to lists in Python. Like you can think of it as a 2D list. And sorry for this computer science terminology. We do not have a lot of time to explain it in more easy language. So you need to provide the X and Y coordinate of this image to know the color in certain pixel. And one important thing for now is that X is not the first in the first break. It's here. It should be in the second. So it's mixed up a little bit. So the first one is Y coordinate, and the second one is X. And let's determine where we want to, what do we want to print. So the resolution of the camera is 320 by 240. So you need to, if I want to print the middle pixel, I want to find the middle of 240, which is 190. Yeah, something like that. And here 159. It's a middle of 320. Okay, and I think this is good for test. Let's run this program. And as you can see, after you subscribe to this topic, you have a ROSPI spin function, which will just keep the program working without closing the program. Because otherwise, if there is no ROSPI spin, the program will reach this point and then finish, quit. ROSPI spin will not allow that. So let's open the simulator and run it again. Okay, and let's fly the same route and have the program working at the same time. So I will run this program, the flight program, in Visual Studio Code, and this program, the 2.py, in the terminal away from it. So here, let's see if it's there. Python 2.py. It is printing the zeros because it's looking at black color. And now let's fly and see how it changed. Look at this. And here it is. Now it's red and green and red. So as you can see, it is working like that. So the basic color recognition, well, color detection is like this. It's very, very basic. You need to do some other things to get it work better. I think we can have a little break for now and continue after the break, because there's a lot of new information for some of you, and I think you would want to refresh your minds in this case. So how do you What do you think about it, Svetlana?
Yeah, so you mean about the coffee break time?
Yes. How about coffee break?
I suggest to ask our attenders. So guys, please write into Zoom chat plus if you need break time, or minus if you don't have it, don't want it. Oh, today was very difficult information, Timofey.
So, yeah, people want break. All right, we can have a break.
Okay, guys, we have 10 minutes break time.
Okay.
And we will continue in 34 minutes. Okay, guys, start in 2 minutes. Be ready. Okay, guys, so the time for break was finished. So are you ready to continue? So guys, if you're ready, please write in Zoom chat plus, and we will see that you are here and you are ready to continue. Yeah, great, great. Perfect. Timofey, our students are ready to continue. No question to us. We are ready.
Almost ready. I will start very soon. I will continue very soon. Yes. Just a moment. Okay, so screen sharing. So I left you with this printing the color in the middle pixel of your screen. This program is pretty simple. It only does one thing, this one. And but we want to actually find colored objects on the scene. And to do this, we need to determine which color we want to have and the color ranges. And we need to change the color mode to HSV. All right, so let's begin with changing the color mode. To do this, you need to call the function. You need to create a new variable. Let's call it EMG HSV equals to CV2 dot CVT color, CVT color. Then there's a source image, which is our image, CV image here. And there is the special CV2, the constant call CV2 dot color BGR to HSV. Color BGR to HSV. So after doing this, you will get this new AMG HSV variable, which has the same type of variable, but with different image coordinates. And we can compare them too by doing this. Let's try this. So print BGR, comma. So in the first print, I put BGR here, and the second HSV, and so I will print IMG HSV, the same coordinates as the CV image. Okay. Just to make sure that we have all correct values. Okay, let's run this program. Also run Gazebo PX4. And run this color recognition program. Oh, I forgot to save it. Save. Control C to interrupt the program and run it again. Okay, BGR HSV, it's still 0, 0. Let's see what happens after we run, after we take off. So to take off, I'll run this program. And as you can see, when you fly above, let's stop here. So when we fly above red, in this case it was red, it shows us 62, 62, 255. So blue, blue, red. The red is the maximum value, and green and blue are 62. While the HSV values are different. So hue is 0, saturation is 193, and the value is 255. And now it is working, great. And for us then to determine, to find the contours of colored objects, we need to do the next thing. In the code, let's add something. So we need to create the new variables called, for example, red BW equals to something, and green BW equals to something. Why BW? Because I will now create a black and white image for each color, and this image will, for example, if you have a photo, say like this. This is a photo, and you have red area here. And I will create the image that is the same size as this photo, but it's all black except for this part. This part will be white. And this is a contour of the red object. And this is why I call it black-white. You can also call it the threshold. Okay, and to do this, you need to call another OpenCV function. I will copy this one from, actually from my reference here in order to save some time. So it is CV2 in range. And this in range function, let's see, is source, lower B, upper B, and dist. Okay, so what is it? The source image is the image that we got our picture from. Then the lower value and the higher value of the color. They should be actually different. So in this case, I will use the lower value 0, 50, and 50, and the higher value, for example, 5, 255, and 255. All right. And one more thing about red color is that it is located in the 0 hue. But 180 is also red. So 179 is also red. And if you want to have a range from like 175 to 5, you need to specify two different ranges for this color. And these ranges should be, I will copy and paste it here. So red BW1 and red BW2, CV2 in range, and the second range would be from 175 to 159. The rest are the same. Okay, so this is a tuple of values, and this is a tuple of values. Tuple is a type of, if it's a data type in Python. You can see parentheses, and it means it's tuple. All right. So we have two different red, black, and whites. And in order to get the color, the combined color, we need to combine these two images into one image. So to do this, we can use red BW without the number equals to CV2 dot bitwise or, yeah. And you give two images to this bitwise or, and the two images would be this one and the second one. So now you get the black and white image for red. I will output this information to screen soon, so we will see how to how to look at it. And for green, we should actually test what green color is in HSV. So for testing purposes, I will run this program again. I didn't save the program, so in my terminal there is still old one working, and it will print me the color. And here I will run the flight program, and let's hover here. So when it's there, I will see which H is there. I think it was 62. Was I right? Well, it's actually pretty easy to test with putting a colored marker here and wait for the drone to land. Where is my name? Yeah, it has the 60 hue, about 60 to 61. But we will have a more wide range, so it's from 59 to 65, or from 55 to 65, better. Okay, I will stop. Oh, yeah, I was wrong. 61 is from BGR, and here is only 60. So anyway. Green BW is, I will copy this one and paste here, but instead of 0, I'll have 55, 50, 50, and 65, 255, 255. Great. I have my variables, and now I need to output them to the screen. How to do that? Let's open the article. There is the article called the computer vision. I already showed you this one. And to debug image processing, you can publish a separate topic with a processed image here. So I will create a new publisher, and I will create a new topic for each color. And let's copy this one. I will create 2 publishers, and I will publish to each of them the image. So where do we create the publishers? Before the function, I will create the first publisher, and the second one, I will call them differently. So the first one will be red pub, and the second is green pub. Okay, publisher. And the name of the topic would be red and green. Is it easy for understanding for you? Just write me if it is easy or not. Okay, publishers are created, and now we need to publish some data. All right, and to publish this data, we need to actually use bridge again. So as you can see here, we used bridge AMG SMG to CV2, but now instead of, we will use CV2 to AMG SMG bridge. So let's publish the first one, red pub.publish. And what do we publish there? Bridge dot CV2 to EMG SMG. And here I will need to, in the arguments here, I need to put some image that I will use. So it's red BW. And then the color space, which is, I think it's mono 8. Mono 8. But it should be in quotes, mono 8. Let's test this one first, only one publisher, just to make sure there are no mistakes. Okay, it's working. And if we open in the browser our local host, image topics, there's red, and it's black. It is black because it doesn't see any red color. If we put some red instead of this green one, I will put the red one and remove the green one. Let's see. And now it's white. So it's hard to tell, but it's actually white. Let's move it a little bit so it's more clearly. Now it's completely black. Now it's half black. Yeah, it's working. The best way, though, is to fly. Let's fly with this program and see how it changes. Is it flying or not? Yeah, I think I need to stop this program first because I have two. So let's stop this program here and fly with this program, and in this terminal I will run my program. Okay, and then, as you can see, we can now detect red color. All right. Okay, what's next? Now let's continue. Let's complete the green part. For now, we're only dealing with two colors because it's faster. And I chose red because red is a tricky one. You need to, as you could see, when working with red, you had to create a special thing with these BW files, BW variables. So here, green BW, and we can also publish this green BW with green pub. I will copy this one and paste here, and then instead of red, I will have green. So, right. And what's next is we can actually create a variable to store which color the drone is hovering over right now. And the easiest way is to create a global variable called color, and it should be undefined by default. Then you can say that this variable is global in the image callback, global color. Otherwise, you cannot access this variable outside of this image callback function. Okay, and then here we can say if red BW and the coordinates of the center equals to 255, which is white, then color equals to red, elif green BW, the same numbers are equal to 255, color equals to green, else color equals to undefined. All right. And we can actually print color in the end here. Print color. And instead of printing these numbers, play this program and undefined. I will rather run this program here, and here I will just play the flight program. It's undefined. Red, 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 green, green, green. And we can find the green topic here. I don't see any green yet. Let's wait a little bit more. Yeah, there is green, of course. Yes. Okay. So, can anybody write me down if you have experience with OpenCV before, if you had experience with OpenCV, and if it's completely new for you, just write that it's new, because we want to know the level of the audience.
Oh, it was a really interesting question for you guys. So please write plus or any short message if you have had or have experience in OpenCV. Yeah, in the Zoom chat. Or write minus if you a beginner in this technology. Your feedback will be useful for us. Depends on your feedback. We will give you information starting from 0 or other level.
And Alexander says, no experience, I missed it all. So this is a new chance for you to keep up with the knowledge. So I hope you find something interesting today.
Yeah, so it's really great when your group of students has the same level of knowledge. Okay, Timofey, so we would like to know about OpenCV from 0.
Okay, so then let's do the next thing. Let's create a program that will combine OpenCV and flight logic, because for now it's a two separate programs, which is not very easy to handle, even for me. And now I will combine these two programs just to make everything I need in one. So there is a way to split screen like that, and I will have one program on the left and the second one on the right. I will also close the left window. And let's see, we need to import what's missing here. So I will import math, then I will import these lines. But please don't import ROSPY init node, because there should be only one init node in one program. So don't import ROSPY init, don't copy ROSPY init node from one program to the other if there is already this thing. Also, I need to get these values, get these service proxies, and the navigate wait. I think I should put navigate wait in some other place, like before def image callbacks, so the functions would be near each other. And the flight logics. Here, instead of ROSPY spin, I will put this navigate wait, and I will remove ROSPY spin, because if, for example, if there was ROSPY spin and I put the navigates after that, it wouldn't work, because the program will never go after ROSPY spin. Okay. So remove it. It's not necessary if there is a way for the program to remain working without closing. Okay, now I can save this and close this window. I have only one window left. And what can we do next? let's do some fun stuff. If there is red color in certain point, then we will then the drone will perform something. If it's green, it will perform the other thing. So here in this world, we have coordinates for the flight. It's 0.5 x 1y, then 1.5 x, then 2.5, and 3.5 x. So those are the coordinates, and we can fly through them. The easiest way would be just typing navigates to this certain position. So let's go to the 0.5, then no, that should be in y. 0.5 and what x? No, I was wrong. The y should be 1 and the x should be 0.5. xy 0.5. Now it's 1.5 and 1, then it's 2.5 and 1. The final is 3.5 and 1. And let's go to the 5 and 1 and land. And after each point, we will print color. Oh yeah. And I will remove printing color from the callback. So the only way to print color is here. And now we can test this program. Red, green. Oh, it hit something. I think there is a problem in the coordinates, maybe. Yeah, because I put 2 for some reason, whereas there should be 1. Okay, let's wait for the. Okay, it landed already for some reason. Okay, and I forgot, I will also need to go back to navigate weight 5 and 0 and 0, 0. Okay, let's try it this way. Okay, and as you can see, it's printing the color, and instead of printing this color, you can, based on the color, make some other functionality. And Svetlana, I have an idea. How about we have Kahoot right now in order to save some time and make sure we don't run out of it. And if we have some time left, I will continue with these topics later. What do you think about it?
I think it is a good idea, but if you have finished the topic, concept of topic, it will be okay for Kahoot, I think.
Yeah, for this part, I finished for this part, and I wanted to give you one more thing, but I don't think we will have really much time for that, so I can show you where to find more information, and well, in the end of the day.
So guys, are you ready to start our mini game? So please write into Zoom chat your reaction on this suggestion. Guys, we don't see your reaction. So please write plus or something else if you would like to join to Kahoot, to mini game.
Oh, triple plus from Bruno.
Yeah.
Everyone loves games.
They need to funny game. Okay. Oh, Lena is here. Lena, our students really would like to join to Kahoot. So are you ready? They want to demonstrate their knowledge of this day.
Svetlana, I need access to share screen.
Oh, just a moment. Give me 10 seconds to solve this problem. Okay, now it should work.
Yes. That is Kahoot time.
Oh, just a moment. We don't hear the music. Or maybe it's only from my side. Oh, it's better.
Yes, but my screen. Sorry.
Oh, guys, now today you're very quickly. You're very faster.
We are waiting for you. Where are you? Sabotage Master, Natasha Davis, Star Bruno.
Okay, guys, we are waiting you, and now you have only 1 minute to join at Kahoot. $40. 30 seconds left. 20 seconds left. So last chance to join to Kahoot. 10 seconds. special delay. 1, and we are ready to start.
Yeah, we are ready to start. Let's go. First question for you. How do you stop a program? Only 5 answers? Yeah. Control C. Second question for you. Which frame is used for flying relative to a single marker? Ten seconds. Yeah, that is our scoreboard. And next question. Where is the Y associated with the frame ID body? Do you remember? Three seconds. 1 second. To the left. One. Only one right answer. Okay. And second question. How do you switch the copter to a disarm state? Only one, only two answers. 3 seconds. 2, 1. Okay, let's go see scoreboard. What should you turn on first? Yeah, that is transmitter. Second question. What should you turn off first? Almost right. Okay. What range is U in OpenCV? Yeah. Okay. What is the callback function used for? Second. Yeah, almost right. And final question for you. That is very difficult. What action will the copter perform when running this code? Be careful. No one. Yes, that is a very difficult question because um, we missed something. And our podium. Third place, Meister. Second place, Bruno. And first place, Tadam. Yay! Congratulations. Thank you, guys. Are you ready to continue?
So guys, we have a question. So what about the questions in the mini game? So it was difficult for you or not? Give us your feedback, please. It was a really difficult exam.
Today it was difficult. Yes, I agree. It was okay. Oh,
Alexander,
bad news.
how it was happen? No problem. In our next events, we will repeat the game and you can join us in the next events. Hey guys, thank you for your feedback. Thank you, Lena, for this exam. It was very useful for us and it will help us to remember the important thing in the drone, in the drone maintenance. Okay, so now we have two topics. So first of all, Timofey will tell you. Timofey will give you some information that will be useful for you in the future, and then Lena will tell you about the CopterHack international project contest for open source drones. And then we will finish our second day of Aerial Robotics seminar. I hope you are here and you are ready, because we are ready to. Yeah, Timofey, please continue.
Thank you. Okay, today and yesterday and today was the event that was meant to give you the basic understanding of what you can do with drones and how you can program them. We didn't have a lot of time to go into much more into detail, but we used to have some more advanced webinars. They are freely available for you, and I want to show you one of them that we had in May, where you can find more information on how to work with OpenCV. I did describe it in much more detail there, and some more cool features with drones. So let me demonstrate you the video from that event. So for example, this one is, let me disable the sound. It shows how to outline the objects in camera. So this is a green outline, and you can outline each color in different color. And in this event, there's enough information to do this. I also went through some interesting functionalities of OpenCV, and we finally tested this on the real drone. So you can see the switch between the simulation and the reality, as well as you can see me and Lena and Sveta there. So we were all there. And I went through some cool articles, which I will give you the link where you can find them. So basically, this is a YouTube video. And this is the day 3. There was also day 2, the beginning of OpenCV. And let me open the videos from that
Oh,
day.
Timofey, could
Yeah.
you share this link with
Yes.
us?
Yes.
Okay, thank you.
So the day 2 was about the beginning of color recognition in OpenCV. Let me send you the link. And the day 3 is more advanced. This is the day 3. Yes, and for those of you who are interested in going into more detail, have fun watching these videos, and good luck with your further knowledge. And what kind of articles we described, well, we overviewed was like, what are contours hierarchies, what are contours in general in OpenCV, so you can outline them this way. How to find the center of the contour of colored object, and some more cool stuff. Well, and you can find all these links here below in the video. Let me show you where. So day 3 materials, open this link, and there is like day 3 folder and useful links, and all these links are represented in this Google document. So have fun working with this, and I hope you enjoyed our event from today and yesterday. And the next part, I think, is for Svetlana. Is it for you? Who will host the next part?
Okay, thank you, Timofey. So guys, now you have an opportunity to ask Timofey, to ask him any questions about the materials. So thank you, Timofey, for these 2 days. It was amazing information about drone technologies. Thank you for your theory and for your practice skills that you demonstrated to us. So, okay, guys, we don't finish it now because we have a topic about our next event. But during this topic, you can ask any questions about material of the first day, of the second day, or maybe you have another questions. So don't hesitate to ask us. We will be glad to ask on your questions, and we are open for it. Okay, so now I would like to ask Elena to tell us about the CopterHack competition. Elena, come back to us again.
Yes.
Okay, and we are ready to listen information about the CopterHack.
Yes. A few words about CopterHack 2022. That is an international open source project competition on aerial robotics. In this year, we have 2 categories, that is own idea and company cases competition. Now you can apply until October 31. each month team sent update for project and get feedback from jury. At April 9 and 10, we have final round that is hybrid format, online at Zoom, in Zoom, and offline in Moscow. The teams present their results of project. We have two general requirements. Project should be open source, and projects should be compatibility with the Clover platform. Here you can see criteria for judging the jury at the final. Also, you can see prize fund and information how to apply. To apply, you should have an account on GitHub and add some information about team and about your project. Also, you can buy Clover platform with 50% discount. Yes, that is all. If you have any question, I'm ready to answer.
Lena, could you show and could you demonstrate the timeline of the CopterHack, please?
Sure. Mm-hmm. Yes. Now we have quality stage. Teams can apply. That we have project development stage. That is monthly updates and feedback from jury. And last update looks like a video in video format at March. And final round will be held at April.
Oh, and one important moment, guys. So the qualifying stage, it is means that you have opportunity to apply for the CopterHack due to October 31st. But if you will apply before this date, for example, you or your team provide the application in September or in August, it means that our team of experts will give you feedback during accepting your application. So, and you have advantages that you have a feedback from experts, and you can ask them about your projects, about your problems, and we will help you before project development stage. So it's a really good opportunity to check your project and maybe provide some changes in this project. And finally, you have more time if you provide the application before the deadline. So, and also one of the good advantages of the CopterHack, it is open and open articles, open projects, open description of projects, and you can take the previous project and you can edit and upgrade it. It will be really great if you start from zero, or you can start from other projects. Oh, I see the question from Natasha. Can I apply without a team and individual application? So, Lena, could you answer on this question?
Yeah, sure. Yes, you can. We haven't some troubles. That is not trouble. It's okay.
Yeah, so this is we don't have requirements for the number of team members in your team. So it means that you can apply as an individual, and in the future you can add teammates if you find somebody for your project. It's okay, because we are glad to motivate the networking during the CopterHack, and the number of the teammates can be changed.
Yes, we have a big community, and you can find team.
Okay, guys, so maybe Timofey, Lena, you would like to add something? Or we can start our evening briefing to finish our seminar.
There is a question, is there any registration fee? No, it's for free, so you can participate for free, of course.
Yeah, the registration is free, and moreover, we provide the online competition and online final stage in online mode, and it allows us to unite the world. So guys, we at the finish, it's a finish on our seminar, and if you have opportunity to turn on your cameras, it will be great. While you're preparing, I would like to say many thanks to our trainers. Thank you, Timofey. Thank you, Lena, for this great material. And thank you, guys. Thank you, our students, for your questions, for your attention, for your interest in this area. And thank you for joining us. It was really great. If you want to say something or ask us about something, you can do it right now or later, depends on your convenience, of course. Okay.
Job there. Yeah, I just took part of the very final, but it looks so impressive and so satisfying to see this thing working. And I've seen how big of a progress you've made throughout last years since I've been involved with the Clover platform last time. And I'm now working in American University, and we are in Unmanned Aircraft Systems Lab, and we're not doing anything even close to this.
Thank you, Sasha. Yeah, it was a really great way starting from COEX, and now in American University. It's really awesome.
Yeah. I will tell you more details in person later.
Yeah, it will be interesting for us.
Thank you.
So guys, now so we are ready to finish our seminar, and before we finish, I would like to I suggest to provide our tradition about the say goodbye together. If you're ready to finish too. So guys, are you ready? Maybe any questions, maybe any something else? Okay, I see you're ready to finish. So, and also I would like to add important information that we will share with you in our Telegram group, the useful links of our community, and don't hesitate to ask anything in the groups and other group of community. We are on connection all time without any weather conditions. So thank you all again, and say goodbye together. You can unmute your microphones. Yeah, bye bye.
Tchau, até logo. Tchau.
Bye bye, bye bye. Пока-пока. До свидания.
Bye bye.